Hello, everybody. My name is Monica Litka, and thank you so much for joining me today. I am very excited to present on today's topic, IPM programs for forest pests. So let's get right into it. This is an overview of what I'll be covering in today's webinar. So we will explore what an IPM program is, examine both traditional and modernized IPM components, discuss the associated benefits, go into details of these components, outline strategies for a successful IPM program, see how you can use an IPM program in your industry, and lastly, explore tools and resources available. So what is an IPM program? There are different ways to describe integrated pest management. One way of describing it is an approach to manage pests in an economically viable, socially acceptable, and environmentally safe manner. Ultimately, it can be viewed as a decision-making process with the objective to prevent pests and pathogens from reaching damaging levels and for determining what actions to take when they occur. The concept of an IPM program has been around for decades, and it's applied to many sectors, including agriculture, horticulture, nursery, golf course and turf management, urban pest management, and forestry. Pests are often associated with insects and rodents, but in the forestry sector, it may also include unwanted vegetation like buckthorn or fungi like Dutch elm disease or oak wilts. The objective of an IPM program is to reduce and maintain the pest population to a level which will not cause significant damage, rather than complete eradication, thereby reducing reliance on pesticides. However, in some instances, when the pest is not established, eradication is possible. For example, with Dutch elm disease, complete eradication for isolated cases is possible. It's what they're doing in Alberta if it's detected early enough. So there are many benefits to an IPM program. An IPM program can provide long-term pest management solutions. In any program, it is important to properly identify the pest and know all available control options to ensure that any controls are properly planned, economically viable, and will minimize potential harm to the environment and people. IPM is necessary because it helps to reduce the need and reliance on chemical pesticides. A successful IPM program ensures that pesticides used will have minimal impact and harm to the environment and to beneficial organisms, while minimizing the potential for conflict with landowners and/or the public. Proper use of pesticides will also minimize the potential for pests developing a resistance. And lastly, adopting an IPM program will maximize the benefits of any treatment plan. The program can result in cost savings, promote environmental stewardship, and improve customer satisfaction and retention. In more recent years, IPM has evolved from a focus on pest control to a comprehensive approach to pest management. So you might be familiar with the traditional components of an IPM program on the left. However, more recently, IPM has been modernized to incorporate a social aspect. And as we know in the field of forestry, planning and organizing, communication and outreach, they all play a very active role. And this is why I like this diagram, because it illustrates the interdisciplinary nature of IPM. We must remember that the methods and strategies employed within each industry can differ. So each industry tailors its IPM approach to suit its unique challenges and requirements. So these traditional components on the left, they generally remain consistent within forestry pest management. And to the right, I combined both traditional and modernized IPM components to reflect what you might see in urban forestry. An IPM program, it can be a single document, but you can also find it integrated into forest management plans. In the next few slides, I'll review each of these IPM components I have outlined. Prevention, suppression, early eradication, and restoration, they serve as the four main project types that guide management strategies. Among these, suppression and prevention are more commonly used, while eradication and restoration are sometimes combined with either prevention or suppression. In the United States, these project types are used to track IPM projects across the country, evaluate strategies and treatments, identify dominant forest pests, distribute funds, and allocate resources. The key to long-term pest management is to prevent pests from initially becoming a problem, right? So it's more economical and it gives better and longer lasting results. So the first image on the left is an image of an oak tree. This oak tree, it was injected, leaving plugs behind. This happened in the month of August. And you can see that this ended up being very damaging to the tree, and the timing of it put it at a higher risk of attracting oak wilt. To minimize the spread of oak wilt, it's advised to avoid pruning or wounding oaks between April and November when sap beetles that spread oak wilt are active. If injections or pruning is absolutely needed during the flight period, you can use pruning paint or grafting wax. But this is prime example of why implementing regulatory guidelines such as pruning bans, like those observed for oak wilt and Dutch elm disease, are vital for preventing the spread of this disease. The next image I have is an example of a triazine treatment used to combat hemlock woolly adelgid. Suppression aims to control and manage existing infestations to acceptable threshold levels. A variety of control practices are used in an IPM program for suppressing pests. Chemical treatment is one. Adjacent to this photo is a picture of the Asian longhorn beetle, which was eradicated in Toronto and Mississauga. Eradication is used as an effort to completely eliminate a pest from an area. It is often combined with prevention in order to prevent pests from establishing. After 5 years of surveys with no detections, the Asian longhorn beetle infested place order was repealed in 2020. And survey work for early detection and prevention are still ongoing. And lastly, an example of restoration involves controlling buckthorn. Restoration focuses on recovering and restoring an area that has been impacted by pests or other disturbances. Moving along, identification, as we know, is crucial in developing targeted and effective management strategies. It is the basis for implementing appropriate control measures while minimizing the environmental impact on the forest ecosystem. Identification starts with accurately identifying tree species and understanding their vulnerabilities to pests and diseases. Next is recognizing and identifying the signs and symptoms of these pests and understanding their life cycles and potential damage they may inflict. Being able to recognize pest lookalikes is a useful skill for monitoring and surveying. So in the photos, I have an image of emerald ash borer, and just below it is another beetle species, just above it is another beetle species. Emerald ash borer has a distinct metallic coloring, which makes it stand out from other beetles. But it's also important to remember that lookalikes can also exist in leaves. So for example, as you can see in the photo, there's oak wilt and bacterial leaf scorch. They look very similar to one another. So an important difference is between the brown and green area where there is a yellow banding. This yellow band is not found with oak wilt leaves. It just goes from brown straight to green. Trees that are infected with leaf scorch, they leaf out year after year and will continue to show these symptoms. A tree impacted by oak wilt, however, will decline and die rapidly. So I took this photo last year of bacterial leaf scorch, so I'll likely be seeing leaf scorch again on this tree this year. And to help with identification, talk with other professionals in the field, scientists, researchers, and entomologists. Even the local landowner and the public, they may have history of the area or on their local trees. Utilizing tools such as lab analysis or pheromone traps can help in precise identification. Regular monitoring and surveillance programs allows to continuously track the presence and abundance of pests or diseases over time. And this helps in understanding population trends and is practical information to use for treatment. Surveillance is data gathering to analyze, monitor, and evaluate the situation. It includes data collection, monitoring surveys, assessments, and regulation. Monitoring provides valuable information that you will need for making pest management decisions. It consists of regular inspections to track pests, monitor tree health, and environmental conditions. This can be achieved by employing techniques like pheromone traps, visual surveys, and inspecting trees for signs of damage or stress, monitoring weather conditions, temperature, humidity, rainfall, or using predictive models to forecast potential pest outbreaks. Setting up EAB pheromone traps, for example, alongside with treatments, can help with treatment strategies, allow for efficiency, and allow for cost savings. The use of soil and foliar analysis can provide valuable information about nutrient levels, deficiencies, pH levels, and overall health. And this information can be used to make informed decisions about control methods. Additional tools that can assist with monitoring is remote sensing technologies like drones, mapping, and satellite imagery. These can all help assess woodlot health and detect changes in vegetation. And lastly, maintaining detailed records of monitoring activities, pictures, observations, and trends over time. If you are a municipality, having a tree inventory will help to keep track of these changes. And this historical data helps analyze long-term patterns and will help make informed decision and strategies. Pest control practices, as we know, are various methods used to manage pests. So cultural control refers to management practices that promotes tree health or deters pest development. Cultural methods take into consideration proper tree and site selection, soil health and amendments, mulching, and irrigation. Mechanical and physical control relies on the use of tools or physical barriers. So for example, following the proper tuning techniques, removal of dead or declining or infested branches, handpicking insect pests, using pheromone traps, or using physical barriers like tree guards. Biological control utilizes natural enemies such as predators, parasites, and pathogens to limit and control the pest population. Natural enemies can control and maintain populations at tolerable levels. So for example, spongy moth has natural enemies such as birds and mammals. There's the NPV virus, there's wasps and fungus. This all helps to suppress and even manage populations. Silviculture control manages the composition and growth of a stand. This includes stand thinning and restoration. Semiochemical are chemical signals that insects use for communication. The two main types of semiochemicals used in IPM are pheromones and allelochemicals, which are used to disrupt mating behavior, repel, or attract insects. Genetic control is genetic conservation and resistance screening. And finally, chemical control as a last resort is typically used when other methods are insufficient or when pest levels exceed established thresholds. And this is why setting thresholds early on in the planning stage is important because it will guide your course of chemical treatments. The most comprehensive IPM programs uses 2 or more of these controls. And when doing so, you want to regularly assess your control measures and make adjustments as needed. Thresholds refer to the predetermined pest population levels where action should be taken to prevent the pest population from causing economic, health, aesthetic, or ecological damage. It serves as a guide for determining when intervention is necessary and how much damage we can accept. When establishing thresholds, pest identification and monitoring data is used to understand the pest life cycle, its behavior, and population dynamics. It involves assessing the extent of damage, including defoliation, dieback, or mortality, and how much of this damage we are willing to accept. Damage assessment helps to determine what control measures to use. For example, during low populations of spongy moth, you can expect to see low defoliation levels. And this is where you might consider physically removing egg masses, larvae, or setting up burlap banding. During medium to high population levels or in outbreaks, triazine treatments or aerial BT sprays will help to minimize tree stress, damage, and protect the tree from secondary pest damage. The next consideration is economic. This involves weighing the cost of potential losses against the cost of your management actions. There are many tools and approaches that you can use to assess trees, and will vary based on your scope of work. When creating an economic threshold for a client, for example, you can add value to a tree by praising it. So you can use a sales comparison approach, which is the market value of the tree, an income approach, which values the present or future benefits of a tree, or a cost approach, which determines the amount of resources necessary to reproduce, repair, or replace the tree. In a municipal setting, if the cost of treatment or mitigation measures, such as a tree injection, is less than the cost of tree removal and replacement, an economic threshold would be set. In a forested ecosystem, for example, where emerald ash borer has killed many, if not all, ash trees, this can be considered suppressing an ecological threshold. The impacts has likely created changes in forest composition by reducing biodiversity or altering ecosystem functions. So restoration efforts such as tree planting may be implemented to maintain forest balance. It is important to remember that thresholds are dynamic and it can change based on new research and findings, changes to pests in the environment, or even client needs. Therefore, it is important that thresholds are reviewed and adjusted as needed. Effective communication in an IPM program contributes to its overall success. It cultivates collaboration, cooperation, understanding, and facilitates knowledge transfer, among other benefits. So engaging the community in the IPM process, it proves to be a valuable approach as it supports our first line of defense against pests, which is early detection, prevention, and eradication. Activities in invasive species removals, adopting street trees, surveying for pests like hemlock woolly adelgid, they're all effective ways to enhance the success of an IPM. Furthermore, effective communication promotes good stewardship practices, awareness, and care for the environment. And for service providers, demonstrating success in an IPM with one client can draw in and onboard new customers. Evaluation aims to review all aspects of the IPM program and how well it is doing at reducing pest population or mitigating damage. This includes not only the success, but it also looks at areas to improve on. There are many different factors that can change over time that will alter your IPM program. So clients' needs may change over time, new research and information may become available, project types and the focus can shift, or even the environment and or condition and health of the tree may change. Part of an IPM program ensures that the environment is not impacted in a negative way. Monitoring the population dynamics of other insects such as bees, wildlife, soil health, and water quality ensures that control efforts do not negatively impact ecosystem function, beneficial or non-target species. Economic evaluation may change over time. And this is why it's important to have a history of data and an IPM program in place so that it makes for informed decisions. And lastly, communication with other professionals in the field is essential for gathering valuable information to improve the success of your IPM program. Learn from others who've already been there, right? And these are a few strategies for a successful IPM program. Proper planning requires the gathering of all essential information before deciding on the best approach to complete the necessary work. So understanding land use on and adjacent to the work area can help avoid potential conflict with landowners or other users of the land. It might also encourage others to get involved in protecting their trees. Environmental impacts on non-target species, soil, water, and wildlife can all be anticipated before start of work and mitigated. Well-planned IPM programs include sufficient lead time to conduct comprehensive external communications with individual landowners, local municipalities, government agencies, local interest groups, and/or other utilities. Communicating your IPM program to the public is also very important to create some community awareness. If you can have more boots on the ground and eyes in the sky, you can potentially be quicker to detect an infected tree. And the last point I want to mention is setting up an IPM timeline. And this ensures that you revisit your IPM approach and evaluate your program. As new information or data becomes available, it will allow you to make adjustments to your program. And having a well-documented history of your work, it will help to track changes over time and be a useful resource for the future. So previously, I mentioned how adopting an IPM program adds value and maximizes the benefits of treatment. Chances are that you're already putting some of these control methods into practice. Not one component of an IPM program is more important than the other, so it should be viewed as a whole approach to managing pests. Having a history of an IPM program can improve efficiency and be cost-effective for you or your client by avoiding expenses. It ensures that resources for control practices are allocated efficiently. An IPM program, it contributes to long-term management rather fixes. This ensures that the objectives and client needs are being met, but also supports the health of the tree. Having an IPM program demonstrates your knowledge and commitment to sustainable and environmentally friendly practices. And a well-implemented IPM program, it can lead to long-term clients, contracts, and attract new clients, which can all be a reliable source of income. So there are tools that you can use to support your IPM. Soil and foliar testing will provide nutrition and deficiency information, which can improve tree health. Analysis is available through commercial and public labs. iTree can be used to estimate and quantify the benefits of trees, which can be helpful for setting thresholds. ID and monitoring tools like EDD Maps and iNaturalist, they're great for tracking and reporting and monitoring pests in a given area. This is a great tool to share with your clients and or the public to get them involved. Continuing and ending this webinar with more tools, the Ministry of Natural Resources and Forestry monitors forested areas in Ontario for insect, disease, and weather-related disturbances like wind or drought. And these maps can be found on their website. Some municipalities will also survey for pests and provide update on their treatment plans. For the emerald ash borer and spongy moth, Lallemont Plant Care provides emergence maps. These maps are produced using a special computer program called BioSim, developed by Natural Resources Canada. It uses degree day accumulation model to forecast emerald ash borer and spongy moth emergent dates. And these maps are updated weekly, usually starting in late March, all the way up until the end of June, and it can be found on our website. So here's a list of the publications I referenced throughout the webinar. If you would like any of these publications, just simply send us an email. And that concludes my presentation, and I hope there was some takeaways.
Any questions, feel free to email us. And thank you.